A long and boring one, but it's a necessary next step in what I want to do. So I've got this voxel plugin I wrote a while back, and it contains some really robust Octree and data model implementations that are have like no precision issues. They use integer long coordinate spaces. So what I want to do is so I rode the parallax harness earlier this week, and I want to start the process of um, figuring out how to go from our data models at very large scales to uh, parallax enabled particle systems. But to do that, all my other stuff's in 5.4, and this was unfortunately something I wrote in 5.5. So I need to create a new plugin and basically clone all this stuff over. So I'm just going to do that in the Parallax Motion project. We're going to make a new plugin. We have our Parallax root plugin here. We're going to add a new one, voxel, um, or maybe spatial data or something like that. And then we're going to start the process of basically regenerating all the files and getting everything copied over. It's a pretty big project, unfortunately. Um, so basically, we need to make all these. So yeah, that's today. But once I get this out of the way, I should have both the things in hand that I need to make the next part. So hang on, I want to get rid of that. Just looking because that message is still popping up. All right, so just quickly go over like what the actual goal is here. Last time I wrote this parallax motion harness, so because we're just in editor mode, you can see that all three of these point clouds are the same exact size. There's one, two, and three, and in the same exact location. But because they're attached to parallax root, when I start up, they will move at different rates as though they were different sizes. So this is important because basically we can't, with the precision available in the engine, make systems large enough to represent galaxies or universes. Um, Effectively, what this is doing is adding another double to the precision that we can handle for scale. So instead of having 64 bits for scale, we have 128, which is a substantially larger space. It does this by applying a scaling factor to the player's motion, and then when the player moves, the deltas of the player movement get applied at some fraction to the parallax roots. So you can kind of see the cluster of quickly moving things back there as we exit. And then we're in the cluster of medium, and then the ones that are barely moving at all are in the large cluster. So the way we could use this is basically we can load these in on the fly and have them behave as their appropriate scale. So we're actually out here, but because we started in the middle and all the parallax motion is working, it makes these point clouds feel like they're much bigger than they actually are. Um, and it's also controllable, like precisely controllable. It's not just act bigger. We can say like I know your actual size is this. I want you to behave as if you're this large. So again, we need those data models. So we're going to go ahead and create a new plugin. And we're going to use the third-party library plugin, and we'll call it spatial data. Or maybe we should just call it voxel. VXL is what the other one was called. It might be the least amount of conflicts if we name it the same. Um, we can use our little screen name here. All right. Ugh. So this is going to be a long and boring one. Pre-warning, we're just converting a bunch of stuff. We're just converting basically an entire plugin that we've already written from 5.5 to 5.4. Yeah, the stars. It's actually, I mean, these are just very simple point clouds. The main thing is the like parallax motion applied to them, causing them to act as if they're different scales than they actually are. Okay, sure. All right, so we got a new plugin here. Probably gonna have to. Is this done? Okay. Yeah. So like I said, we might be able to see it more clearly if I start out here, but too far away. Maybe here. And now, because we were so far away, we'll encounter the quick moving cloud first, and then we would encounter the medium one, and then we would encounter the large one eventually. Um, Even though they're all in the same place, and it's because basically what we're doing is applying some fraction of the player's movement delta to the root of that these are children of. And that formula is I think I'm trying to remember, it's like play, layer movement frame delta times um, actual scale over virtual scale, and it's actually 1 minus. So, yeah. Uh, yep, and then plus current position. I think that's basically what I'm doing here, and then so there's other things I got to figure out. Like I'm still not sure that this is the way that I want to do it because you could also think of it like this. Let's say the base unit in Unreal Engine is centimeters. Let's say we want to generate a particle system where our base unit was kilometers. Well, we could just do 1 to 1. We wanted to occupy 100,000 kilometers, so we make our scale of the actual particle system 100,000. But then in our actual to virtual scale, we give it a centimeters to kilometers would be 100,000. So we give it 100,000 over 1, or no, 1 over 100,000 ratio. And now your 1 unit in terms of your particle system is actually an entire kilometer instead of a centimeter. And that might actually be the better way to do it, but we'll kind of cross that bridge when we get to it. Um, so I think what we're gonna have to do right now. So the problem is that okay, this is my existing voxel plugin. Here we go. So this hasn't updated, unfortunately. So I think every time we do a big change, we have to tear this down and close it and maybe even regenerate project files, which is annoying. Um, so here's this project plugins. Yes, okay, so we do have the plugin here. Um, oops, this one. And there may be a way to make it like there's still some things I want to investigate because like placement of objects is going to be tricky. I know you could say where's your actual position, where's the player's position. Let's draw a line, and then use that ratio of the actual size over the virtual size to figure out some point along that line to place it. Um, but I do want to investigate other methodology there because like it could be as simple as like what scale is your base unit scale, and then maybe we could figure out a way to do it with just purely static world coordinates, so like the player's frame of reference. But I'm not sure yet. The okay, so did this finish? I think it did. We can actually. Okay, yeah, this is what I was looking for. I don't want this to do anything. I can get the message and seek it out. That's what I'll do. But this will probably be a pretty long and arduous process. But this is like the last thing in the way to start building like the universe down to galaxy and star system level particle systems, and then like we'll kind of go bottom up from that point. Yeah, here it is. Okay, so loaded example library DLL. Or actually, let's do Control Shift F from third party. Where is that message coming from? Comment that out. This out. Comment this out. I don't think this would ever happen. But if it did, we would get rid of this. And this and this. Okay, great. And then inside voxel, wait, I'm gonna need to look at the data structure. The distance fixed in relation to the player, change the scale instead. That you never reach a star, then you can transition at some point to actual placement. Keep the distance fixed. Oh, I see. Yeah, you could do it that way too. Like you could like there's definitely a relationship between scale, but like I think the from what I've seen, I think the parallax solution is probably the most graceful because it does map onto like if you want it to be like 1 unit and then we just change the size that the unit is. So like 1 unit is a centimeter, 1 unit is a kilometer, 1 unit is 1,000 kilometers, 1 unit is 1 billion kilometers. Like, and then we're just basically changing that ratio of how much parallax is applied per the amount you move. Um, but yeah, and then the nice thing about that is if you want to change speed, like you can just change that ratio. Okay, here's this. We're gonna have to clean this out of here too. So let's take a look over here. Okay, so under source for this, um, future. Okay, so we got these three. So let's go over here. Let me see. So there are some build files here that will probably have issues. U plugin file, voxel plugin file. All right, let's just do this. I think I fucked up actually. Yeah, let's do this. Need to double check. Uh, if I want to delete the plugin, a a plugin, and with a different name, can I just delete plugin root for the folder? Close the editor. Okay. Disable, delete folder. Okay. I think that's fine. Alright. So, delete. Generate project files. I mean, I'm just trying to create it with the exact same name so that like all the auto generated files don't flip out and I copy paste them in. I'm sure there's going to be problems, but trying to create as few problems for myself in the future as possible. All right, we're back. What? I closed you. And then you got to keep in mind, like, whatever we do, it has to be compatible with rebasing, because we're gonna have to. What are my build errors? Parallax root CPP obj. It's in the intermediate folder, so maybe if I just were to come over here to delete. Excuse me? I probably can't do it while this is running. Yeah, okay, that makes sense. Drive data cache, and then let's just go ahead and one more time. Yeah, so the rebasing, because pretty much all of my data models are my own stuff. I think we can manage it. The idea is that like all our coordinate systems except for the lowest level one are virtual. So they actually shouldn't need to be rebased beyond just like being told like, hey, we're rebasing, move your route, which it should do automatically. Um, but yeah, we're gonna have to basically put like a, I don't know, 100 billion unit box around the origin, and when you exceed that, you rebase. Um, the bright side is that we can change the speed at which we move through that space with this parallax stuff. So rather than like actually having to go a billion miles an hour to make any progress between stars, we can just fake that part of it by changing like the parallax parameters, and like unloading whatever like current star system you're in. Change the basically the units of speed that you're running at. Like instead of moving at centimeters, we're moving at kilometers and things like that. Okay, so can I start it up? But that is part of the. Okay, we have the same problem. Link, parallax root, creating library, one unresolved, parallax root, unresolved, external. Alright, so rather than me reading through this, I'm going to jam it into Coworker and see what they have to say about it. Okay. Excuse me, Control Shift F. Sample library function. Parallax root CPP file. Okay, yeah. So right here. Oh, yeah, of course. I don't need any of this. Not yet. Okay. There we go. Alright, that was it. I've done it. It does have support for rebasing. I think it runs on like I don't remember how they do it, but like I've done rebasing before to test my planet mesh stuff and see if it behaved properly. And for the most part, it did. All right, we're back, baby. So now new plugin, third-party library, voxel plugin. No, no, no. Voxel plugin, so that my name can be the same as the existing one. Okay. Do this again. I'm getting comfy with this one because I'm expecting it to take a while to get this right. All right, now we're good to go. Now, I must admit some degree of fear of just pasting this shit in here and seeing what happens. But fuck it. Go ahead and delete this as well. Alright, so I fully expect this to be full of errors. Get rid of this. Holy shit, is it gonna... There's no way... I would be so astounded if this just worked out of the box. That would be incredibly unexpected. There's no way. It is compiling real-time mesh, though, which means that it picked up the CMake hooks in the build file for the plugin. Boop, 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 boop. Okay, yep. There's no way. No shot. No fucking shot. No fucking shot. So it appears to have just worked. So that's nice. Okay. So we got our octree. The sparse voxel actor here is what we need. I think it was sparse. Well, let's find out. It's choking a little bit. What is it doing though? It's definitely chugging. It's trying to do something. Some issues in the real-time mesh stuff. Which is fine because we don't actually need the real-time mesh stuff from the voxel meshing. We just need the sparse voxel data model with the N64 coordinates. Yeah, no, like it's just like it's the kind of thing where when I do it and nothing goes wrong, I don't trust it. You know what I'm saying? Like it's so finicky all the time. C++ is so goddamn finicky all the time that when I go in and I copy something and it just works out of the box, I'm like, no, this is wrong. I don't trust it. Type was loaded after. Why am I hitting breakpoints? I don't trust it. I don't trust it at all. It's also not meshing, at least it doesn't appear to be. Unless it's just meshing it like way, way bigger. Okay. Now we got some errors, which is fine. We should probably close this. Regenerate again. Make some background copyright free, uncopyrightable. Yeah, exactly. It's like it's like there's some things I do and I don't expect it to break and then it breaks and it freaks me out. And then there's other things I do and I expect it to break and if it doesn't break, it freaks me out. It's like this didn't break. There's something fucking wrong. I know it. 'Cause I expected to be fighting like dependencies and shit all night. Get out of here, dude. Hawk your shit to somebody who gives a fuck. All right. Does this look okay? I mean, that looks right. Oh no, it's the wrong project. Fuck. I'm a dingus. I looked into some of the links you posted, by the way, and it's a bunch of cool stuff, but it's the kind of thing where, like, I would probably have to sit down and sink my teeth into it for like a week to really even have a good idea of what it's even talking about. What happened to my shitty music? Okay, there it is. Um, the wait, stop. Why is it doing this? Stop. Okay, looks good. Um, yeah. So I was looking at the links. Like the buffer stuff. I like the vertex buffer stuff. Like I get that. The binary tree stuff that I was looking at is like, yeah, I would have to sit down probably and like bash my head on that for like at least a week to even understand what it's talking about. It looks cool though. Did you just swap languages mid song? That's cool. I found that with the AI music, uh, the lyrics are usually pretty cringy. So just generate lyrics in languages that you don't understand. And then you don't have to worry about the lyrics being cringy. My favorite's Old Latin. All right. Uh, let's go. Let's go. Come on. Okay. So we got to figure out. I got to remember how to use this. Okay. This is. Okay, so adaptive voxel actor is the one that's supposed to render mesh. I think it was, I was doing it like really large. But I mean, I'm not seeing it forming any mesh. So like something's going on. Yeah, well, I mean, like at the end of the day, anything, any data model could be just mapped to a flat array. If it like, you just have you have to define like the array very carefully. But like anything could be one dimensional, even. Um, which a binary tree can also map into a 1D array. So like, it's definitely interesting on that front, and like it sounds like it's more parallelizable, so it can go to the graphics card more efficiently, which makes sense because like your individual calculation per like triangle or per chunk could be slower, but able to run in like a much like more parallelized fashion, and like that could be better if it can go on the graphics card. Uh, but then like the quad tree is just like very intuitive. Like it makes more sense to me as like a human to look at that and like understand what it's doing than it does to look at the binary trees. The binary trees are very like, this is how like a computer would think. You know what I'm saying? All right, so let's delete this. This is not what we want. Sparse voxel actor, I think, is the one we want. It shows octree, make shared, sparse octree. Okay. This is the one we want. Yes, yes. Like, because, okay, actually in here is my, like, not complete voxel meshing algorithm. And that is similar in that, like, I don't have, like, I have chunks, sort of, as in, like, I have a certain level of the octree that I can hold, or the, yeah, a certain level of the octree that I can hold on to and say that that's a chunk. But, like, all the calculations are at the individual vertex level, so there's not like, it's, I don't know how to put it, it's not as easy to work with, but it has advantages because it's a lot easier to like, an SDF is just like inherently more manipulable as a like math function than like a flat height map that goes on the surface of a sphere. Because like with the SDF you have depth, so you can control like you can terraform basically, which is really nice. Um, and I have an implementation if I can get it to work, which is what we're basically trying to do right now. Um, did this come with a level? I don't think I knew to do that yet. So we could actually think of this as like, okay, if our actual scale is 1, say we wanted to go from 1 centimeter to where 1 centimeter in this system actually equals 1 kilometer, then it would be 1 to 100,000. And then if I turn... So like, that would turn this into like centimeters equals kilometers. We don't even... That's kind of what I'm thinking though. Like, I don't think we even need the relative scale of the thing. We just need the, like, scale factor we want of the base scale. So like, if the base unit is centimeters, we want some multiple of that. And then we can just like, we're basically defining how big one unit is with relation to how we move in the system. And then all we have to do at that point is figure out placement, because placement is going to get altered too, because like, if you put it at its normal distance from you, like its actual distance, then it would be like 100,000 times that. So it would be like much bigger already. But yeah, one of these is not going to move now. Actually, let's do this. One, two, three, two, one. So this is 100,000. Yeah. So now they're all the same. This is just kind of fun to mess around with, actually. Oop. Oop. Okay. Okay. This is like if these are moving now as if they were a kilometer away for every centimeter they are away, which is like almost imperceptible. So I would have to increase the player pawn speed. Oh, here's one. We'll never get there because it's like actually far away. We can just control it like that. So I actually don't even need this. I just need this, and we just say it's in relationship to the base units. And that tells you like, oh, what's my base unit in the scale? And we can determine the base unit in the scale from the depth in the octree that the thing is found at. So like, the galaxy is going to be at some depth in that octree is going to be the object that we check to see if we need to load in like a galaxy of stars. So that would be like maybe these guys, since they're so far away. When we get close to one, we swap it out for another particle system that is the actual galaxy. We approach that, and the scale factor of that will come from whatever depth they're at in the octree, because that'll, like, if we say our base distance in the octree is 2 centimeters and we have like a 30 depth, then we can figure out like how big that base unit is. Or actually, wait, no, this is the base unit right here. And then we have some multiplier where we can increase like the distance that we move relative to everything. Let me get close to something here and then start it. So I'm close to this one. Where is it though? Wait, what? Why is it? Well, I can't find it. There's one here. And then, okay, yeah, I'm getting it. I'm getting it. So if we have an octree level with stuff in it, right? We get the base. I'm just planning this out. We have the base scale derived from the depth that it's at, and then we have some translation to go from what its coordinates are to like the real world coordinates at that scale. So the last real question is how do we place the things when we load it in? Because they can't just go into the world position that they would be at in the octree. We have to do that conversion as well. So we can get the scale from the depth, and with the scale, we can figure out where it should be placed by its virtual scale. So it would just be like inverted probably. Yeah, because one unit in that scale would be like this, and then we just reverse that and use that as like one and place it in centimeters equals that unit, so it stays relatively small. And I think that's it. I think that's all. I think that's the last kind of puzzle piece. Finally got close to one. It's doing like a little flicker there that I don't like though. I'm gonna have to figure out if it's even viable because we could do this in a shader probably. Yeah, it's too far. I need a faster pawn. I'm way over here. Let's see. So hang on. This is bugging me. Excuse me? Oh my goodness. Okay. I'm gonna look at this too. Fast geometry streaming. Well, that sounds interesting. It's pretty nice. This is good because I want to use this eventually. Like, that all sounds good, you know? Like, I don't have room on my computer to download another engine, though. I'll check back in at some point and upgrade again, but at this point, it's a pain. All good, dude. Why is this still running? I'm surprised. So, like, the engine crashed, but the debug session didn't? What the fuck? Something going on with the real-time mesh build. Aha! Okay. This is it. So... hang on. Okay, just the inside of the modules. Let's see if this fixes the meshing. 'Cause that would definitely cause problems if I didn't have the dependency loaded. Maybe. You're saying run the copyright free shit through a pipe to that and then just listen to whatever music I want? Because like that really is the only downside of this, is not being able to listen to copyrighted music while you do it. Let's see. Is it gonna do it? It started. Nah, it's all fucked up. And I may have more missing like project settings. Yeah, it's not a bad idea. It's like probably more work than I'm willing to go into. I'm very lazy. So you're getting a real-time mesh recompile. That's good. Everything built. Fuck. It's this. I think it's this. So then we need here, 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 and then we probably need to just close everything. All right, one more shot. Come on, work. Work, you bitch. Alright, so far so good. No breakpoints either. I think I got it. I think it's gonna work this time. Okay. So... Oh, this is marching tetrahedra. That one doesn't work. It's this one. Put this... let's send you to the origin. Yeah, okay, we got it. Alright, so... There's still some issues with this, and I need to pull in the right noise libraries. But this is all, like, from a voxel SDF here. Hang on. Stimulate. and it works in the same kind of like there's no, it's not processing things in chunks basically. It's just adaptive in real time. But this is a lot harder to scale up than this is a lot harder to scale up to like planet like sizes. And you can see I've got some math issues here that are happening at certain angles, and I'm not sure why. And that's why I need to get the fast noise libraries in here so that I can actually use a noise generator that I'm confident works. And if I could do that, then this would be like potentially usable to do planets. I just have to figure out how to get it large scale. But yeah, so that is the adaptive one though, and that's not what I need. Whoop, okay. This just feels unlucky to me. How does this happen? How is destroyed calculated? This is so like somehow I feel like this is just bad luck. Like there's definitely a problem there, but maybe it's intermittent. Yeah, so it's a dual contouring implementation. Um and it works pretty good, but I don't like I to just do like the SDF for the test. I don't have the noise libraries that I have like confidence in. So I was just using like the built-in Perlin. So it's possible that it's a problem with like the noise function or like my assumptions about the noise function. Uh, or it's either that or something going wrong in like my dual contouring implementation. Yeah, so here we go, here we go. So what I have is a Taurus SDF modified by just FMath Perlin Noise 3D, scaled by like the size in a factor. And then I'm just modifying the point by some value like that. So it's possible that one of my assumptions here is bad, but I don't think so because it's on multiplication. So it's probably, I'd be interested to see it with like a fast noise. But that's not the one I want anyway. I want this one. But I don't think I use this one like this. So sparse voxel actor. This is a data structure. Uh, okay, this one might work too now. Yep. Alright, this is just the data structure. But it's looking at like whatever the base voxel size is here. And it's populated a sphere in the octree, and it's like so this lets us visualize the filled layers. I got a problem here though. Jesus. Third person map. Parallax for yeah, I use Fast Noise 2 on the planet project, the quad tree stuff for the like planet noise formulas. There's some tricks with that too. There's some ways that you can combine noise that get like kind of more diverse natural results. You can kind of generate like fault like mountain ranges and things like that. Okay, so this is one solid. I have what are my other demo options here? Here. Make it a little bigger. That's chugging a little bit. Know what this? I think this needs to be spawned in a different way. All right, so we got to figure out how to map octree layers to. I need like paint or something to scribble around in. $32. Let's say 32 depth. What? We have a 2 scale at that depth. Because, like, how much depth I can actually get in here? It's so I have to look at my sparse implementation here. Alright, this is what we want here. Alright, so the next trick is we have to, using the parallax, figure out how to do like a conversion between this being the real world scale, and then it needs to go through like basically an adapter layer to become like parallax scaled. And then we could take the contents of any layer and just run it through that conversion and have it behave at that scale, even if it's much bigger than it could normally represent. So you can use this to basically fill point data. So what we need, just thinking. Okay, so okay, so next we're gonna need our point cloud stuff, which is in different project. I gotta go pull that up because I. Okay, so we got. I didn't expect to get this far today. I was expecting getting this plugin working to take longer. Um, so now what I need to do is start putting pieces together. And the first thing we're going to need is to convert our point cloud functions that are currently blueprints into C++ so that I can multi-thread them to make them faster. And I'm just thinking about how to start with that to be like, so I think I stop here for the moment. I'm gonna have to hunt those down and get that working again in the other project. Because I had a galaxy like generation thing already in the other project that with this little parallax component could become a lot more powerful if I can just figure out that basically adapter between the two, between the nodes, like actual scale in the data versus its scale in the world. Okay, so I need to go find my other projects. Okay, so in this, oh, did I do this already? I might have. No, I think I just did two of the easy ones. Globular. Oh no, I do have a spiral here. Interesting. So am I using that? I didn't think I had done that yet. So I get the galaxy stage working again. And then I can pull in the parallax thing. What it's basically, what I think it'll basically allow us to do is define like an actual like unit scale for a given layer and have the layer do its movement, like its positions and numbers, as if one unit was whatever the scale is, which will make it behave like it's much bigger, but it'll actually still be in a smaller space. So it should still have precision, hopefully. Okay, that was an error in the level that was deloading. I didn't like switching levels there. All right, back online. So fuck, man, I can't switch levels. I gotta do. I guess I could delete the planet. I delete the planet, then I should be able to switch. Should be able to switch levels again, and then I can debug whatever's wrong with the galaxy particle system. Okay. recent levels. What's another level I can do? Okay. I managed to switch levels. Oh yeah, this was that lava material. Why am I going so fast? Alright, so yeah, like I think maybe something went wrong in one of the materials for this, because obviously this is a bit overwhelming. Um, this one. Don't say that. Yeah, okay. Here we are. So the material's fucked up. Where is my material getting set? Somewhere I'm setting a material on this, and I need to find the material. It's not construction script. NG Galaxy. Here it is. Okay, this is what I was looking for. And then in here, renderer. Sprite material. Okay, so Ah, so where's my material? No, that ain't it. This is it. So that's what it needs. Okay, that's correct. But particle material is not set to anything, so that's a problem. So it's dust, dust. Okay, it is that. Okay. So what if I change? Okay, that's getting closer. Okay, that's not. That's too much. That's also too much. Is something happened with the transparency here? I think something's happening to the transparency. Dust right. Yep. Combine these to get like their total intensity. Something like somehow this material got broken. I don't know how. Yeah, there it is. Okay, so our now our um, alterations here. Maybe say 0.4. Okay, so now we have these, but we can make them a lot bigger. And Galaxy, our Galaxy blueprint. There we go. But there's some like fighting here going on that I gotta sort out. It's like that's not gonna work. But if it was, that's in the material. Oops. Okay, we found one. Can't change those like by hand. I'm probably gonna lose those changes I just made, which sucks. I think I remember where they were. One was in the material. They probably saved. Probably saved the material change. Okay, another cool thing this has is if I play it. Okay, yeah, never mind. It's not working precisely well. I think I have to be in. Oh no, it's working. You just need the actual player camera. Okay, not precisely. I forget the controls that I set up for this. I have something to target. Is it like T maybe? Okay, yeah. There we go. Okay, it sort of works. We have a problem in the dust sprite here. And then the dust cloud properties. And then if we wanted, we could also make this... What happens if we make it additive? And then we can get rid of this. That might have been what happened. It might have been swapped. Oh, it's a lot better. Except for that. The distance scale factor is getting too high there. So... Need to look at this. Does have local space. Alright, so it's already configured properly to hook in. You gotta figure out why it flickers when moving. Like, just for a second. Like, okay, not moving. Moving. Not moving. Moving. Looks fine while moving. Looks fine. Stop. Flickers. we got this back online. That's nice. Yeah, that's too small. The only problem with this is that it's like too bright when you're in the middle of it, but I guess we could control that by reducing the density of the noise. What if we turn this up quite a bit and then change the distortion amount? Change the dust distortion scale to like 8. It's not too bad. Alright, and then if we wanted a darker, like we could just say quarter. Yeah, there we go. So all this has got to do is be attached to a it's got to be attached to a correctly scaled parallax root. And you got a galaxy. And then at some point, probably about like right here, where it's just outshining, we convert it into a single. So like there's gonna be a transition, right? Like you got the larger one, and when that one is hitting about here, we like swap in this one, And also, okay, I remember how this works now. And I'm reasonably certain that the like flickering issue here can be fixed. All right, so part of that's going to be material issues. See, I don't know what to do about that flickering. This is also using the additive. So if I do this, yeah, that's what I expected. It multiplies the effect. So if you want to do it this way, you have to do... No. Translucent. Like the way I'm doing this query needs to be a cone and not just like a line, which is why it's so hard to get things to select here. If I was sampling inside like a cone, it would be easier. Alright, so get rid of this. Does this need to be two-sided? I don't think it does. Okay, no. Yeah, that flickering. All right. And how is the point cloud for this being generated? Where's my point cloud generation value? Hang on. Yeah, this is still using this, which, yeah, so we started doing this, but I don't think we ever finished it. So, like, instead of generating these huge bounds, we can just generate the point clouds in like a 0 to 1 space and translate that by the scale that we want it to be at. So we really need to get, what we need to do now is to get that uh, parallax thing into this project, which is actually pretty easy. Because it's just a component. So I can actually just migrate that, I think. I understand. Okay. So we need to save everything. File, save all. Go and close this. And then this is going to stop. Excuse me? So now we go in here. I do know one way that I could um, make the. I think I know how to stop the flicker effect. It's just a lot of work. I have to change the way the system works a little bit for the galaxy. So right now it's one sprite, one particle system. So our main issue here that we're having is that the way this sprite works is it's rendering like this really small dot in the middle of a much bigger sprite. Like we can't even see the edges of that one from there. It's this big. And the dot is only in the dead center, and we're actually hitting like the limits of what the material can do with how small and bright we can make this thing. So I need like one particle cloud for the gas and another for the stars, I think. And break up the responsibilities, and then the star particles could be the size that we want the stars to be, and we could change, like, it actually adds an extra layer of like customization. So that's what I'm going to need to do next, I think, as well as, hang on, 0, 1, 2. Oh, I made the parallax route. Hang on. Okay, hang on. Let's try this. That's not working yet. Not working yet. Alright, so next up. I, probably need to get some dinner here. I think I'm gonna chase polishing this galaxy function, getting it attached to the parallax root. Right now, these are just proof of concepts too, so everything is on the CPU and it's not multi-threaded at all. So like, we have to optimize all of the generation of that stuff on the fly because right now it takes too long. But the good news is it should be very optimizable. It's almost like it could literally be done in a parallel 4 and that would do it. This is entirely too big. Let's go ahead and do this. This does not need to be... I need to put the gravity plug-in in here too. This does not need to be the size it is. I'm gonna fix that and then hop off.
escape? Who do you call when you're losing your faith? Who do you trust when your heart is betrayed? Don't you worry.